Hey guys, this is Hayden. This is going to be our first video in our proof of L'Hopital's rule. Now in this video I'm not actually going to be proving anything. It's just going to be a quick review of what L'Hopital's rule is, under what conditions we can use it, and some applications. Okay, so under what conditions can we use L'Hopital's rule? So the first thing is we have two different functions, f and g, and they both have to be differentiable. And we also need the derivative of g prime of x, to not equal 0 on an interval which contains a. So if these two conditions are met, then L'Hopital's rule says that if the limit as x approaches a of f of x over g of x equals either 0 over 0 or infinity over infinity, these are two indeterminate forms, then the limit as x approaches a of f of x over g of x is equal to the limit as x approaches a of f prime of x over g prime of x. So now that we know what L'Hopital's rule says, let's try and do an example problem real quick. So let's say we're trying to find the limit as x approaches 0 of e to the x minus 1 over sine of x. Okay, so now with any limit problem, the first thing we're going to check is if we can just plug in the number we're approaching. So if we're going to plug it in, we get this is equal to e to the 0 minus 1 over sine of 0. Well, e to the 0 is 1, so we have 1 minus 1 over 0, sine of 0 is 0, which is 0 over 0. Okay, so we got 0 over 0, which doesn't really help us in solving the limit, but we do see that it's one of these indeterminate forms, so maybe we can use L'Hopital's rule. But first things first is you have to check our conditions. So we have to check, are f and g both differentiable? So in this case, it's in the form f of x over g of x, so our f of x is e to the x minus 1. So e to the x minus 1 is differentiable everywhere, so that works. And our g of x is sine of x, which is also differentiable everywhere, so f and g are both differentiable. Okay, the second condition we have to check is if g to the x is not equal to 0 on an interval which contains a. Okay, so in this situation, a is 0 because a is just the number that x is approaching. So we need to check g prime of 0, and we want this to not be equal to 0. Okay, well g of x is just sine x, so g prime of x is just going to be cosine x. Okay? And then if we plug in 0, g prime of 0 equals cosine of 0, which equals 1. So g prime of 0 is not equal to 0. So all our conditions for L'Hopital's rule have been met, so let's apply it to our limit. So L'Hopital's rule says that the limit as x approaches 0 of our original function is going to be equal to the limit as x approaches 0 of the derivative of the top over the derivative of the bottom. Okay, derivative of e to the x minus 1 is just going to be e to the x. Remember, we still have a limit here, so it's just going to be e to the x. And the derivative of sine x is just cosine x. Okay, so now let's try and plug in the value we're approaching again, and we get e to the 0 over cosine of 0 equals 1 over 1 equals 1. Alright, so this was a pretty easy example of L'Hopital's rule, but hopefully it was a good refresher on when we can use it and what some of its applications are. Now we can get started with the actual proof.